Okay, Trig, this is part 2 of section 8.3. We're going to do these 3 problems, which involve a little bit more algebra than just kind of what we were doing up above. We are going to skip example 10. I don't want to really go through the quadratic formula. And then I went ahead and got rid of, we're just going to treat all of these problems the same, and we're going to do the plus 2 pi n or plus pi n on the end of each one of them because, yeah, I don't want to have to worry about only find the solutions from negative pi to pi, okay? So each one of these equations we're going to solve the same way, but we just need to, figure out what to do first. Okay, so we need to get it to the point where we can solve and get sine of x by itself. And this guy is a trinomial. If you see like sine squared, sine, and then a number. What I like to do to start with, we've solved these before, is I like to switch them to just x's because that helps me to think about it a little bit better. And then what I'm doing is just from here, I'm solving it just like a complex trinomial, okay? So in a complex trinomial, I take the first part times the last part, so 3 and negative 2 will make a negative 6, okay? And then I look at what factors, or what numbers can I multiply together, give me negative 6, go on and add them, give me negative 1, okay? And that's going to be a negative 3 and a positive 2, okay, in that case. So now I just rewrite them in 4 pieces, so I have 3x squared minus 3x plus 2x minus 2, okay? So this guy really kind of broke down into those 2 pieces, and then I factor by grouping, okay? So this is that complex trinomial method. From here, we just pull things out that we can, so 3x squared minus 3x, I'm going to pull a 3x out, and I'm left with x minus 1. Okay, this second piece, I'm going to pull a 2 out, and I'm left with x minus 1. Okay, and I know I did this right because the x minus 1s are the same on the inside. I'm kind of going through this fast, so if I'm going too fast, kind of pause the video and just kind of collect your thoughts, I guess. Now my 2 pieces that I have left over, final, is 3x plus 2 and x minus 1. Okay, so from here, we would normally set them equal to 0, right, which is what we're going to do. So if I set 3x plus 2 equal to 0, I would subtract the 2, okay, so 3x equals negative 2, and x equals negative 2/3 is what that would look like, okay? This one is just easy. I just add the 1 over, so x would be equal to positive 1, okay? Now, here's the tricky part, though. We're not dealing with just x. We took x and replaced x with sine of x, so it's actually sine x and not just x. Sine of x and not just x. Okay, so now we have sine of x is negative 2/3 and sine of x is 1. Okay, and so what we're going to do is we would do the inverse sine, just like we would do before. The inverse sine of both of these things. And so x equals inverse sine of negative 2/3. Okay, so I'm going to do that one first. Okay, so in my calculator, I'm going to plug in inverse sine of negative 2/3. That's what he is. And I first get an answer of negative 0.73, let's say. Okay. If I do inverse sine of 1, x equals inverse sine of 1 here, okay. I actually have, well, no, I don't have 1 on the unit circle for sine, so I'm going to do this. Well, yes, I do. I have inverse sine of 1 on the unit circle. So, inverse sine of 1, right? Let's see, on the unit circle right here, inverse sine of 1. He is 1 at pi over 2. Okay, and really, that's the only place that he is evaluated at 1 at. Okay, he actually doesn't have a second set of solutions because, down here at 3 pi over 2, he's at negative 1. So that doesn't really count. So I'm going to do pi over 2 for him, and I'm going to do plus 2 pi n. Okay. Anytime you can look these up on the unit circle, you want to make sure and do that. Okay. The only other thing down here, I need to make sure and put plus 2 pi n here. Down here, negative 0.73, I want to use the rule of sine to figure out what his other value is. So I have another value instead of negative 0.73. And the rule was, I think I have it written up here, sine of x will be the same as sine of pi minus x. Okay, so to get my second answer, I need to take pi and I need to subtract this value, and that will give me the second place where he's going to touch. So pi minus a negative 0.73 will give me 3.87. 3.87 plus 2 pi n. Okay, and that will be my next, or my second answer. Okay, so just like what we were doing before, except we have to kind of work a little bit harder to get to that point. Okay, all right, this one goes a little bit faster. Example 8 is solve for this function, solve for this equation here. So I have a tangent on both sides, but I don't just want to, don't just want to divide it out, because then that will get rid of the tangent entirely. So what I'm going to do is I'm going to subtract this tangent and get everything onto one side. Okay, so that will look like tangent x cosine squared x minus tangent x equals 0. Okay, and then I'm looking at this as a binomial, and I'm trying to figure out what to do from here. But what I notice is that both of those have a tangent x in common. So if I pull that out in front, this will be cosine squared x minus 1 equals 0. Okay, let's see, I'm going to run out of room. No, that's okay. All right, so now that I have my two pieces, I say tangent of x equals 0. Okay, and I'm going to get an answer. And I say cosine squared x minus 1 equals 0. Okay, so tangent x equals 0, and I do have a 0 on my unit circle. So I'm trying to figure out where tangent is 0. So there are two places where tangent is 0. Over here at 0 degrees, and over here at 180 degrees, or at pi. So we would say 0 and pi are going to be my two answers for x. So x equals 0, and x equals pi. And then what I need to make sure and do is add that period onto the end of each one. So the period for tangent is pi n and pi n. Now, in the last video I told you that tangent is kind of beautiful in the fact that his two solutions can be just written as one solution. Because if you notice here 0 and pi, if I see 0 plus pi n, that kind of covers pi, right? Like he'll touch pi if I plug 1 in for n. 0 plus pi times 1 is just pi again. So I really don't need this solution because this one kind of does it for me, or covers that for me. 0 plus pi n is going to already touch every interval that second one is at, okay? So I can kind of nix that part, okay? Now this one, for cosine, I'm going to add the 1 to the other side. So I have cosine squared x equals 1, and then I would have to take the square root. But remember that the square root is plus and minus 1, okay? So now I'm going to look on my unit circle and figure out the places where cosine is positive 1 and negative 1. Okay. So looking all the way around here, let's just look for positive 1. I'm looking for the x-coordinate or cosine to be positive 1. Okay. The only place cosine is positive 1 at is at 0. Okay. So I know that I need 0. Right. And then the only place he's negative 1 is at pi. Okay. So I have 0 and pi, and each one of these will be plus 2 pi n. And plus 2 pi n. Okay, now we look at kind of like the solutions that I have, and 0 plus 2 pi n is going to touch every 2 pi and intervals of 0, but I'm already kind of touching those by saying that 0 plus pi n is there, and the same thing with this. Pi plus 2 pi n is going to be touched already by every place 0 plus pi n. So this is going to cover both of those. So really, I can limit it down, and I only need to write that one solution, 0 plus pi n, because that's going to cover all of these other places. Okay, if you want to go ahead and include them, you can, but it's just kind of redundant. You wouldn't necessarily need to write those other three because this is already touching those intervals. Okay, all right, last one. I'm going to write this one down here so I have enough room. Here we have a cosine squared and we have a sine in there. And basically I want to work in just one trig function. The way that I got away with doing that up here was that they were multiplied together, but this is subtracting the two trig functions. Okay, so one thing that I do know is cosine squared is a Pythagorean identity. It was like, I don't know, sine squared plus cosine squared equals 1, right? So if I'm solving for cosine squared and I want to get cosine squared by itself, I would subtract a sine squared, okay? So cosine squared will be 1 minus sine squared. That's what I'm going to plug in for this cosine squared up here. Okay. So after we plug this in, it's going to be pretty basic. Instead of cosine squared, I'm going to put 1 minus sine squared. Okay, minus 3 sine x plus 9 equals 0. Okay, and then I'm just going to solve this. This is going to look really similar to example 7. Okay, so we'll just do another one of these. So I'm going to distribute my 10 through. So I've got negative 10 plus 10 sine squared x minus 3 sine x plus 9 equals 0. Okay, so I'm just putting together stuff. I'm going to link the negative 10 and the 9 together. And then also at the same time, I'm going to switch these to x's because I'm going to have another trinomial. So this first one, I'll have 10x squared, really x being sine, minus 3x, and then negative 10 plus 9 is negative 1 equals 0. Okay, so now I'm kind of at the same spot I was in example 7. And we're going to do this as a complex trinomial. So the first step is 10 and negative 1 makes negative 10, and then I'm thinking, what two numbers can I multiply together to give me negative 10, but when I add them give me negative 3? That would be like negative 5 and positive 2 is what I can use. Okay, so now I'm going to write them as 4 pieces. So 10x squared minus 5x plus 2x minus 1 equals 0. And then I'm going to group those things. Okay, so things that I can pull out of 10x squared minus 5x, I'm going to pull a 5x out, and I get x minus 1. No, 2x minus 1. 2x minus 1. And then 2x minus 1, there's nothing I can pull out, but I'm going to pull out a positive 1, because you always have to take something out. Okay. So then my two pieces will be 5x plus 1 and 2x minus 1. Okay. All right, now, if I set each one of these equal to 0, I'm going to go kind of fast through this next part. If I set 5x plus 1 equal to 0, I'm going to try to do some of this in my head. I would subtract the 1 and divide by 5. So subtracting 1, dividing by 5 will be x equals negative 1/5. Okay, this other one, if I do that in my head, 2x minus 1, I would add the 1 and divide by 2. So x would be 1/2 there. All right, now, last thing that I need to do is, it's not x, it's actually sine x, and sine x. Okay. So to get this x by itself, I'm going to do that inverse sine again. Okay, so x equals, I'm going to do inverse sine of negative 1/5. Okay, so I do inverse sine negative 1/5. And I get negative 0.20. Negative 0.20 plus 2 pi n. Okay. Now remember from sine that when we do it on our calculator, it's not going to give me both of the answers, so I need to find the other answer. And the other solution for sine, the rule is I take pi and I subtract that value. Okay, so pi minus the negative 0.21 that I just got will give me my second answer. So I'm going to do pi minus that answer, and I get 3.34 plus 2 pi n. And that's going to give me both of my solutions that I get for this one. Okay. Last one, I have sine is 1/2, and I do have 1/2 on my unit circle, so I'm going to look at those. Okay. So I need to figure out, there should be 2 places where sine is 1/2 at. Okay. So 1/2 is the y coordinate here at pi over 6. Okay. So I'm going to label him as pi over 6. And the other place where sine is 1/2 is at 5 pi over 6. Okay, 1/2 and 1/2. Those 2 places, sine is 1/2. Okay, so I have pi over 6 and 5 pi over 6, and each one of those is plus 2 pi n. Okay, so this is another one where we have a combination of things that we're going to look up on our unit circle, and another one that we're going to use our calculator for. Okay, but that rule still applies to pi over 6 and 5 pi over 6, right? Pi over 6 is my x, and if I take pi minus pi over 6, I will get 5 pi over 6 as my second answer. So that's kind of reflected on the unit circle again, and just kind of consistent with what I had before. Okay, so that was a lot of work, only 3 problems, but it's kind of a little bit confusing. All right, so hopefully that was enough repetition, enough problems for you to kind of start to understand. Okay.